This video is hypothesis testing the null and alternate hypothesis, part 3. So we were talking about type 1 and type 2 errors, and we were about to do an example when we ran out of time in the last video. So let's just review what type 1 and type 2 errors are. We make a type 1 error if we reject the null, but it was a mistake and we shouldn't have because the null was actually true. And we make a type 2 error if we fail to reject the null and it was a mistake because the null was false. So we already went through this in the past video, so let's start with example 1. Suppose Frank tests his rock climbing equipment and the null is the equipment is safe. So let's write the null and the alternate statement up here. So the null is that the equipment is safe. The alternate statement has to be contradictory. So what contradicts that the equipment is safe? It's to say that the equipment is not safe. So a type 1 error. A type 1 error only happens when we reject the null as a mistake. So we are rejecting, let me use red ink. We are rejecting the null. We're saying that the null is not true. We're saying the equipment is not safe. That's what we're saying. But that's a mistake because it really is safe. So we have made a false statement. So we have stated we're rejecting the null, we're saying the equipment is not safe. In reality, the equipment really is safe. That's an example of a type 1 error. A type 2 error happens when we fail to reject the null. So we did not reject the null. Okay? Instead, we don't have enough evidence to say that the equipment is not safe. So we fail to reject the null. So we are implying that the equipment might be safe. That's what we're implying when we don't reject the null. We're saying we don't have enough evidence to say that the equipment is not safe. But as we said, this is an error, which means the equipment is really not safe because we should have rejected the null, because this failing to reject is a mistake when it's a type 2 error. So those would be examples of type 1 and type 2 errors and what they would mean for this particular situation. Okay, so type 1 and type 2 errors for the victim of a car accident is brought to the emergency room and the null is that she is alive when she comes in. So pause the video and see if you can figure out what a type 1 error would be and what a type 2 error would be. And when you come back, we will have the answer. Okay, so I like to write what the null is. The null is that she is alive when she comes into the emergency room. The alternative to that is the contradiction that she is not alive. So type 1 error happens only when we reject the null. But the null is really true. Okay, so if we reject this, it's basically we're saying she is not alive when she is. That's what that would mean. For a type 2, if you fail to reject the null. That's a type 2 error is always when you fail to reject the null by mistake. So if we fail to reject the null, that means we can't reject saying she's alive, so we're saying we don't have enough evidence to say that she's not alive. So basically we're implying that she might be alive, but in reality, she is not alive. Because, again, we should have rejected the null. We've made an error when we failed to reject the null. So we made an error, we failed to reject the null, and we should have because she isn't alive, and if it were a type 2 error. Okay, so that leads us to types of tests. So there are quite a few different tests that we'll be learning, but in this chapter we're concentrating on 3: a z-test, a t-test, and one prop z-test. These sound very familiar because we've done a z-interval, a t-interval, and one prop z-interval when we did confidence intervals. And they are very much related because we are going to use a z-test when we're testing a claim about a population mean and the population standard deviation is known. It is known. And that's the same way we knew when to use a z-interval, was when the population standard deviation was known and we were trying to estimate a mean. Now, if we're testing a claim about a population mean and the population standard deviation is not known, if it's not known, and we probably would know the sample standard deviation, or we have the raw data and we could find the sample standard deviation, in that case we would use a t-test. Just like if this were the same thing but you were trying to estimate the mean with a confidence interval, you would do a t-interval. So it's the same reasoning behind the two. And if you were testing a claim about a proportion, you're going to do a 1 prop z test. Now once you run the test, you're going to get some information back, and you're going to have to make a decision and draw a conclusion from that. So let's look at this example from a certain textbook, not our particular textbook. Didi and Ali are at a birthday party of a very wealthy friend. They hurry to be first in line to grab a prize from the tall basket that they cannot see inside. There are 200 plastic bubbles in the basket, and they have been told that there's only one with a $100 bill. Didi is the first person to reach into the basket and pulls out a bubble. Her bubble contains a $100 bill. That seems really unlikely that the first person that draws a bubble gets the $100, right? So let's say the claim were true. If the person throwing the party told the truth, that there was really only one $100 bill in any of those bubbles, then the probability of Didi drawing a bubble out and getting a $100 bill on the first try would be 1 out of 200, because there's 200 plastic bubbles and only one has a $100 bill in it. And that's equivalent to 0.005, which is less than 1%. If you change that to a percent, that's 0.5%. That's half of a percent. So that's a very unlikely thing. It's considered a rare event that has occurred. So because it's a rare event, they begin to doubt that the information that they were given was true. They're beginning to think, hey, maybe this person lied, because that's very unlikely for her to get the $100 bill on the first try. So in reality, they would weigh this against the probability that the person who told them this was lying. So how likely is it that this person lied to them? And if they trusted the person, they wouldn't doubt their word, because they would assume the probability of the person lying was even lower than 0.005. So when we do a hypothesis test, it's a similar situation. We're going to make an assumption. So over here, we assumed that the party thrower was telling the truth about the $100 bill. So in the beginning, you're going to make an assumption. That is your null hypothesis. That's your assumption. So if the sample we get is a reasonable result based on the assumption we made, we don't reject the null hypothesis. So, for instance, if if we assume that she's telling the truth and there really is only 1 out of 200 that are the winning bubble, and we decide, okay, based on this sample evidence, and if this assumption, this null hypothesis, if this is true, how likely is it that we're going to get this sample statistic that we got, this sample result? Is it reasonable? So basically what we're going to do is we're going to figure out the probability of that sample result happening, and if it's less than what we consider unusual, then we're going to reject the null. And if it's not less, which means it would be a reasonable result, then we don't reject it. Now, in the past, we've used 5% as what we consider unusual, but in each problem, we can redefine what we consider unusual. Sometimes we consider unusual 1%, sometimes anything less than 1%, sometimes we consider it anything less than 10%, and sometimes we consider it anything less than 5%. So it will be defined in the problem, and we'll talk about that in a bit. If it's not defined, assume that unusual is 5%. So that brings us to p-value, a p-value. So basically what happens is we take the sample and we get the sample mean or the sample proportion, we get the sample data, and then we find the probability of that result happening again if you took more samples. How likely was that result in happening if your null assumption was true? And that probability that we find is called the p-value. That's the probability that our sample results would occur given that the null is true. How likely it is that it would occur. So what we do then is once we find this p-value, this probability, and it's defined here. The p-value is the probability that if the null were true, we would get a sample as extreme as we did. So if that probability is low, lower than whatever we have defined as unusual, we will reject the null. Because what we're saying is, okay, this result is so unlikely, it's so unusual, that the only explanation is our assumption was false to begin with. So we reject that assumption, we reject the null. If p is not lower than what we consider unusual, we fail to reject the null. Now again, what is low? In the past we've considered 0.05 as low, but it will change depending on the problem. We use something called a predetermined significance level. We use this lowercase alpha. Lowercase alpha represents significance level, and it's what we consider to be unusual, what we're going to compare our p-value to. And our significance level is basically the probability of making a type 1 error. Okay, so we are almost out of time on this video too, so I'm going to stop it here, and we're going to pick up with part 4. And we're going to learn how to use the calculator to run the z-test, the t-test, or the one-prob z-test.